everybody. Okay, so last week was about collecting your data, so now this week is about analyzing and reporting out the results of your experiment. So you have your 10 objects, and then I'll just use a Google Sheet like this, and then you have to get data from 3 of your classmates, right, and then just list it here. So then you'll have like 40 data points, and just copy and paste it, right? And then you have to watch out, because let's say, like, if I measured things in inches, but maybe the data from somebody else is like in centimeters, then you have to convert so that everything is the same. So I would maybe just make another column like this, and then this can be centimeters. Centimeters. And then I'll just do a conversion, like say equals, and then this times 2.54 centimeters per inch, right? And then just gonna drag over here. So then this is that times 2.54, and then just take these, and right, if you go in the bottom corner, that little dot, and then just drag it here, then it copies the formulas. Let me align these nicely. Okay, and then there we go. So then you can have all your data just like in centimeters. Let me move these over. I don't want to. Right, let's focus on this. Like, this is your table plus all the other data here. And to graph it, right, just highlight these two. The first column will be the horizontal axis, and the second column will be the vertical axis. So for example, like if it were like this, circumference would be on the horizontal, diameter would be on the vertical. That's not really what we want. We want it this way. Okay, and then just go insert chart, and then like there's different types you can pick, right? Like you can do it like this, columns, line. Really, we want a scatter plot of just dots. So here, scatter. These are analogous operations if you're just using like Excel or something else. Okay, and then there we go. Or let's here, and then I would see these dots up here in the corner. You can click here, and then you can edit. And then I would definitely like at least change the title. Well, I guess this is called circumference versus diameter. That's correct. Maybe we don't need the units in the title here like this. Okay, and then we have our label here, our label here. So next we want to know, like, we want a fit to the dots, a trend line. So if you go here, edit chart, under customize, there's right like chart style, chart and axis titles, series. So use series, and then if you scroll, this is trend line right here. So see, it already inserted this trend line, and then you can like change the color, make it like darker looking. Right. There are different types of fits. Like you can do a different like a higher degree polynomial. That's not really what we want. We just want a linear fit. And then you scroll under label. We want to like use the equation so that we can look at it. Right, so it says the equation is 3.23x minus 3.12. So the slope is 3.23. Right, so that means no matter the size of the circle, the circumference and the diameter were proportional. Right, so all the dots fall roughly along that trend line, and the slope of that was 3.23. Okay, we were expecting pi, right, like 3.14, So that's what you can report. You say, okay, my data, I got a slope of 3.23. I was expecting pi. So that's a measure of the accuracy, right? Like 3.23 compared to what you expected theoretically. So that's accuracy. Precision would be more like I use my tape measure, and then I could only get values to the nearest 16th of an inch, for example. But let's say somebody else used like a ruler that had marks that were to the nearest millimeter, or like someone else used like digital calipers that were in increments of like zero point 0.1 millimeters. So that's a measure of precision, like how many decimal places you can get for your measurement. And then there are other ways to quantify it. Like when you measure something, you could measure, like if I measure my water bottle, let's say I measure it and then I kind of reset and then I measure it again and then I do that 100 times. So I measure the same object 100 times, and then I can take the mean and the standard deviation of those 100 data points. And then the standard deviation is kind of a way to quantify the precision of my measurements. We can do that in a future lab. Okay, so now for reporting, I would just, since we're already like in the Google environment, I'll just open up a Google Doc, and then you can basically follow this format here. Like don't forget to write your name and then some kind of title. And I would use, see, like if I highlight, if this is my title, and up here under styles right here, like you can say, I'll make that title, right? And then there are section headings, and you should have like an introduction, and let's make that, I'll pick one of these headings, 2. And then next section is methods, and I'll use the same heading style. And you should try and practice using this like heading style. So these are my different sections. Each of them has a heading, because I mean this right now it's like a 1-page paper, right? Maybe it'll extend to 2 pages, but there, now it's 2 pages, right? So you could, under insert, you can insert, see way at the bottom here, table of contents, and then you can have like with links or with page numbers. So you see like it automatically generates a table of contents. So you say, okay, I want to get to the conclusion, and then there's a hyperlink that takes you straight to that section, where you say, okay, I want to get to the results section, where you click here, it takes you straight to the results. I mean, not such a big deal. I wouldn't even include a table of contents for a paper that's 2 pages, right? But just so that you know about the feature. Okay. So the first section, introduction, just say like the purpose of this lab is we wanted to explore circles and the relationship between circumference and diameter. And then the hypothesis is you were expecting that no matter the size of the circle, circumference and diameter were going to be directly proportional, right? And that would be pi. Okay, and then you just explain, next section, methods. You just explain what you did with enough detail that if somebody else were reading it, they can do what you did, right? So you say, okay, find 10 circular objects, measure the diameter, with some ruler, measure the circumference, and then you have to explain how do you measure a circumference if your ruler, I mean, a tape measure can bend, right? But what if you have like a wooden ruler? How do you measure circumference? You can take a string, right? So you explain with enough detail there, and then you're good. results, you just say, okay, the results of my experiment were as follows, and I would just copy and paste the table and the graph straight from your Google Sheet. So let's say let's make like a border so it looks nice. There, okay. Right, so you highlight here, copy, like copy here, like copy, Control C, or like Option C if you're on a Mac, right? And then straight to your Google Doc, and you just paste it, like Control V, like here. And then it'll ask, do you want to link it? And you're like, yes, I definitely want to link it. Because if you go back and you make some changes, I don't know what we can, let's say I'll make these bigger or something. Right? Like you make changes to your table here in the Google Sheet, those changes will reflect here. You just click update right here, and then it's automatically linked. So that's pretty convenient, right? And then same for the graph. Like you say, I'm gonna, right here, it's like copy chart. Did you see I clicked here in the corner, copy chart, and then back to the Google Doc, and then just paste. And same, it'll ask like, do you want to link it or not? And I'm like, yes, I want to link it. Right, and then here, it's here. So then if you go back to your Google Sheet and you make changes, let's say I want to, what kind of changes? Let's say I make the dots a different color, and I make this trend line a different color and thicker, right? And then when you go back to your Google Doc here, see that update link button shows up, you're like update. Right, so that way, right, everything is actively linked. You don't have to copy and paste back and forth. So just for convenience. Okay, and then next section, analysis. You say like, what are different sources of error? You say, okay, well, definitely I was limited to the precision of my tape measure being only like 1/16 of an inch, you know, stuff like that. Like I couldn't get a good circumference when I measured a bucket. Like I had a hard time getting the string. You just explain those things. And then conclusion, you basically just restate the hypothesis and then restate you're just wrapping up, right? Summarizing. The hypothesis was this is what I got. And you can even quantify the error. You can say like the error was some percent, and then it can be like, you can just define, like you can just take the absolute value of your measured result minus the theoretical. So you say like my slope was 3.23 minus pi divided by the theoretical, like pi. And then it's like something percent, right? And then that's one way to quantify the error. And there are different ways to report the error. This is one way to do it, as long as you explain how you got it. That's all. Okay, and then if you used any research references, like you have a research paper, you can just cite that paper using APA format, and then you can have some references here. Okay, and then when you're done, just like, right, just save this as a PDF and then just upload it to Lalima. Okay, so any questions, just post it on that community support forum and then I'll respond. Okay, other than that, I'll see you next time in the next video.